Hi guys, today I'm going to be teaching 2.1, graphing polynomials. Functions. Now, what is a polynomial? Well, poly means the word many, and nomial is the term. Let's see if I can focus this more. Now, a term. A term is like 3x negative 3x squared, that's a term. 2 over 3x to the fifth y squared is a term. Coefficient is the number part of a term. Now, for example, if I gave you 5x squared, 5 is called the coefficient. The coefficient is just the number 5 itself. A degree of a term is the power or the exponent So for example, if I gave you 5x cubed plus 7x squared minus 1, right here the degree is a 3. Right here the degree is a 2. Now right here, there's actually an x to the 0, you just don't see it. So this has a degree of 0. Now, next, if you guys have something like this degree would be 7. 5 plus 2, you add up the exponents. So the degree here would be 7 in this term. Now, sometimes it's going to ask you for the highest degree. The highest degree is just the one with the largest exponent there. Leading coefficient. A leading coefficient is the number in the very, very front. Okay, it's a number in the very front. Leading coefficient. For this example, 5x cubed plus 7x squared minus 1. Right here is just going to be 5. The leading coefficient is the number 5. All right, next we're going to go into classifying. Let me see if this light makes it worse. Okay, next we're going to go into classifying polynomials. So on classifying polynomials, let's first do the number of terms. If you have one term, that's called a monomial. If you have two terms, that's called a binomial. If you have 3 terms, it's called a trinomial. And if you have 4 terms and so on, we just call it the n-nomial for whatever number after that. The degree, if the degree is 1, like you have x, just x, that is a linear function. If the degree is 2, like you have x squared, that is a quadratic. So here, if you have x, that's just linear. If you have an x squared, that's a quadratic. If you have a degree of 3, which means x cubed, that is called a cubic. And a 4 is called a quartic. That's about the height that you might see it. Okay, let's go into graphs of polynomials next. Graphs of polynomials. Now on graphs of polynomials, if you have an odd function, we're going to be paying attention to the tail ends of the graphs, okay? So if you have an odd function, like an odd degree, so y equals x to the 1 power, right there, it's just going to be a straight line going left to right. So what happens here is the left side is going down to negative infinity, but the right side is going up to positive infinity. You're going to pay attention to the tail ends. We're going to be paying attention to the end behaviors. So right here, if I have a y equals x cubed, that's going to look something like this. So on odd powers, the tail ends, one is negative, one is positive. Okay, one is negative, one is positive. Now if you have an even, say you have an x squared, your tail ends go the same direction. That's what x squared looks like. And look, they're both going up at the end. If you have a y equals x to the 4th power, I'm going to kind of exaggerate. It's going to actually look like a W. They're both going up. So just know that if you have an even degree, the tail ends are going the same direction. If you have an odd degree, then the tail ends go opposite directions. Okay, so just keep that in mind. So the end behaviors right here, these alternate. So either down up or up down. Okay, these end behaviors alternate. We're on the even. The end behaviors are the same direction when you're looking at the tail ends. They alternate directions at the tail ends. So I'm just going to show you a couple of examples. If I gave you y equals 3x to the 4th power minus 7x squared plus 2, you are only going to look at the degree. So right here, the degree is the number 4. So what does that tell me? That tells me that the tail ends have to go the same direction. Even, so the tail ends go in same direction. So either they're both going up or both going down. Now, you have to pay attention to the leading coefficient. If it's a positive, that means that the tail end has to go up at the very end. So right here, the leading coefficient equals a positive 3. So because it's positive, the right end has to go up. Right end has to go up on the tail. Okay, on the tail. I'm going to type this in my calculator right now. So I have a 3x to the 4th power minus 7x squared plus 2. I'm going to graph it. So now I'm going to look at my graph. And as you can see, look, it's going up and up. The tail ends are going the same direction, which I knew that because the degree was 4. And I said that they had to go the same direction. Now right here, the right end has to go up. If I look at the right side of it, it has to go up because the leading coefficient is a positive. So this graph looks like this. So when asked what's happening it's going up. As x is getting larger, it's going up. And on this side, it's going up. It's going up on both sides. Now let's do an odd example. Let's say y equals a negative 3x cubed plus 2x minus 1, okay? Right here, my degree is 3, so the degree equals 3. So because that degree is an odd number, I know the end behaviors have to alternate direction. So either one's going up, one's going down, or one's going down, one's going up. So they have to alternate directions on the tail. And then because the leading coefficient is a negative 3, the leading coefficient equals negative 3. Because it's a negative number, the right tail end has to go down. Right tail end has to go down. So I'm going to plug this in my calculator, negative 3x to the third power plus 2x minus 1. And there's the graph right there. So I'm going to sketch it. And look, they are alternating directions. One's going up, one's going down. And because the leading coefficient is negative, the right tail end is going down. The right tail end is going down. Now, this is a notation for the end behavior. Now, you have 4 quadrants when you're looking at the Cartesian coordinate system. This is your x-axis. This is your y-axis. This is called quadrant 1, and we use Roman numerals when we're listing our quadrants. This is quadrant 2. This is quadrant 3. This is quadrant 4. In quadrant 1, as x, the x here is going to positive infinity. The y is going to positive infinity. Which in quadrant 1, the coordinates are positive and positive. In quadrant 2, as the x is going to the left, x is going to negative infinity. And here the y, because it's going up, that is positive infinity. And how do we know that? Well, in this quadrant, all x's are negative, all y's are positive. Right here, they're both negative. X's are negative and y's are negative. So because they're both negative, as x is increasing, it's going to negative infinity, and as y is increasing, it's also going to negative infinity. And then in quadrant 4, the x is positive, but the y is negative. So that means x is going to positive infinity, but the y is going to negative infinity. All right. I just want to review a couple of things before I let you guys go and start working on the assignment online. You're going to have to be putting it in standard form. Now, standard form always goes in descending order. So this is just some homework help. So if I'm saying standard form, if I told you 5 minus 3x to the third plus 7x squared minus 4x plus 2x to the 5th power. In order to put that in standard form, you have to go in descending order. So first put the highest exponent, which is the 2x to the 5th. So that's going to go first. Next, it's going to go the next term, the next exponent. So after 5, I have an exponent of 3. So that's going to be a negative 3x cubed. I'm crossing it off so that I know I already used it. Next is going to be x squared. So that's going to be a plus 7x squared. Next is going to be a negative 4x. and a positive 5. So if it tells you to put in standard form, you are putting it in descending order based off the exponent. Now, let's say it's asking what's happening on the graph. Okay, well, we know that the degree is 5. And what do we know if the degree is odd? If the degree is odd, it alternates, okay? If the degree is odd, we know that it alternates. So right here, the end behavior alternates. So it alternates. So it's either one's going up, one going down, or one's going down, one's going up. And then because the leading coefficient is a positive, the leading coefficient is a positive 2, that means that the end of the end has to go up. So that means the right tail end is going up. So I'm going to start by drawing the right tail end, okay? The right tail end has to go up. And the degree tells me how many changes I'm going to have. Look, 1, 2, 3, 4, 5. It's going to look something like this, okay? This is 1 change, 2 change, 3 change, 4 change, 5 change. And look, what did I say? Because the degree was 5, the end behaviors are alternating, so they are alternating. One's going up, one's going down. All right, one's going up, one's going down. So right here, what can I say? That the x is going to positive infinity as y is going up. And right here, as x is going to negative infinity, y is going to negative infinity. So right here, I would say as x is going to infinity, positive infinity, y is also going to positive infinity. Right here, the y is going to negative infinity because you're going to the left. So right here, as y is going to negative infinity, x is going to negative infinity, the y is also going to negative infinity. And think about this. If this is in your Cartesian coordinate, you're looking at the top right quadrant and you're looking at the bottom left quadrant. So the questions on your homework is going to ask you, well, what's happening when x is going to negative infinity? So as x is going to negative infinity, what's happening? The y is also going to negative infinity. And use this table as a reference. All right, I will be posting these notes in case you guys missed anything. And your homework assignment is already online. It's in the Google Classroom.